Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. This is the continuation of my video on ISC curriculum physics for the 11th grade, and we were on to the chapter number 2, that is on units and measurement. Okay, and I am referring to the book called Kumar and Mittal, right? And in this previous video, that is I think video number 3, okay, I had covered units, okay, the chapter number 2 I had started with, and I had covered a certain part of it, and I'm just going to continue from where I left last time. And today I'm going to start with something called light year, something called parsec. Okay, so these are nothing but the bigger units of length or distance. Okay, so one light year is what? One light year is a distance traveled by the light in a vacuum in 1 year. This is the definition of one light year. Okay. So this happens to be the definition of one light year, right? So once again, I'm repeating, one light year is the distance traveled by the light in vacuum in 1 year. Now you know that the speed of the light when it travels in vacuum is 3 into 10 raised to 8 meter per second. This is the speed of the light. Okay, and you know that the formula for speed is speed equal to distance upon time. Now if you rearrange this formula, you will get distance is equal to speed into time. Okay, so distance will be equal to speed times time, speed multiplied by time. The speed of the light is 3 into 10 raised to 8 meter per second. This is in the SI system. And time is what? You'll have to take the time as 1 year, but then the unit for time is seconds. So 1 year, how many seconds are there in 1 year, that you will have to calculate. So in a year there are 365 days. In a day there are 24 hours. In 1 hour there's 60 minutes, and in 1 minute there is 60 seconds. Okay, so if you want the answer in seconds, okay, the answer will be this. In 1 year, the time in seconds should be this much. Okay, what is that? 365 into 24 into 60 into 60. Now this time in seconds multiplied by speed, that is 3 into 10 is to 8. If you multiply this out, okay, you will get a value as 9.46 into 10 is to 15 meter. This is nothing but one light year. Okay, so one light year is equal to 9.46 into 10 is to 15 meters. Okay, so this is a very important relationship that you get, right? One light year is equal to 9.46 into 10 is to 15 meter. Fine. Now we are going to study another unit which is used for measuring bigger distances, and that is known as parsec. Okay, one parsec is what? Now here I am just touching the topic of parsec, the definition part of it. Then later on I'll be explaining you more in detail how you have to understand the meaning of parsec. Okay, so for now you just remember that one parsec is what? Parsec, the full form is parallel parallactic second. Okay, what is the full form of parsec? Parallactic second, and it is denoted by PC. This is the symbol. Okay, remember we are dealing still with the units of distance. These are the large distances. For measuring large distances we use these units. Light year is used for measuring large distances. This parsec is also used for measuring very large distances. Okay, so one parsec is what? It is the distance at which the average radius of the earth's orbit around the sun cuts an arc length of 1 AU. 1 AU is 1 astronomical unit, would subtend an angle of 1 minute, 1 second. Sorry, this is 1 second. Okay, so this is a definition. Now by the definition you won't understand anything much, but I'm just giving a touch to the definition, and this I'll be making you understand a bit later during the end of this session. Okay, so just remember that 1 parsec is equal to 1 AU upon 1 second. Okay, and 1 parsec is equivalent to 3.1 or 3.2 rather into 10 is to 16 meter, and it is also equal to 3.2 light year. Okay, now these are the two relationship between parsec and the meter, parsec and the light year, which I'll be coming to before the end of this today's session. So just remember this. This is just to tell you that parsec is nothing but a bigger unit of length or a distance. Okay. Now there's one more bigger unit which is known as AU. AU stands for astronomical unit. Okay. What is AU? AU is astronomical unit. Now what is this astronomical unit? You know that sun in the middle, you know, there is a orbit uh, around the sun in which the earth is revolving. So this is sun, this is earth, and this orbit is not perfectly circular. Okay, it is not circular, it is slightly elliptical, right? So when the earth is revolving around the sun, now earth takes 365 days to complete one revolution around the sun. So when the earth is traveling in the orbit, okay, around the sun, you can see that the distance, between the earth and the sun keeps on changing. Okay, throughout its journey the distance keeps on changing. So if you take the average of these distances, that is the average distance between the sun and the earth, that average distance is known as astronomical unit. So one astronomical unit is what? It is the average distance of the sun from the earth, right? And it has been found out that 1 AU or 1 astronomical unit is equivalent to 1.49 into 10 raised to 11 meters, which approximately can be written as 1.5 into 10 raised to 11 meter. So 1 AU is nothing but 1.5 into 10 raised to 11 meters. Okay. Now, parsec. I told you I'll be revisiting parsec. Parsec is what? 1 parsec is equal to 1 AU upon 1 second. Now, this is the formula. Now, you won't understand this formula right now, but this is the formula for parsec. Now, the parsec I will explain you by taking this example. Okay. Now, this is where you can understand this astronomical unit and parsec. Okay, this is the concept of astronomical unit and concept parsec. So 1 AU, that is 1 astronomical unit, is the average distance between the sun and the earth. So here in the diagram you can see that there is sun in the middle and this earth is going round the sun in the orbit which is not exactly circular but it is slightly elliptical. So every time the distance between the sun and the earth keeps on changing, right? Sometimes the distance is more, sometimes the distance is less. So if you take the average distance between the sun and the earth, that average distance is said to be as 1 astronomical unit, and it has been found to be 1.5 into 10 raised to 11 meter. Is that clear? So 1 astronomical unit or 1 AU is equal to 1.5 into 10 raised to 11 meter, or you can write 1 AU is equal to 93 million miles. In miles you can write it in this way. In meter you can write it in this way. So that was all about astronomical unit. So you know what is an astronomical unit. It is also a distance measuring unit and it is used for large distances. Now let us come to this concept of parsec. Now to understand this concept of parsec, first you should understand what is the meaning of parallax. Okay. See, if you are observing any object against a background, okay, of a more distant object. Now, suppose you are keeping your finger in front of your eyes, and behind your finger, there's a open sky like thing. Okay, so that sky becomes a distant object, and the finger becomes a near object. And that near object, when you see with your eyes, what will happen? The parallax is the apparent shift of the nearby object with respect to the distant object, distant background. So what you do, when you hold your finger in front of your eyes, and if you try to see your finger by closing one eye at a time, okay, you will see that your finger shifts. Okay, it will be moving against the background. So sometimes it will be on the right, sometimes it will be on the left. Okay, so when you try to see your finger with one eye at a time, you will see that the finger is shifting. This particular phenomenon is known as parallax. So if you hold your finger in front of your face and try to see it through each eye separately, then you will see that your finger shifts with respect to the background. Now, if you want, you can just, try it now itself. keep your finger in front of your face and close one eye, close your right eye and try to see with the left eye, then close your left eye and try to see with your right eye. That way you keep on doing it, you will see that the uh, finger position will be shifting with respect to the background. Okay, this phenomenon is known as something called parallax. Now the same thing can be seen also if you see a nearby star with respect to far away background. Now somehow in the night, if you are trying to see some far distant star, okay, so behind the star also there is a lot of background. Okay, the universe is very huge. Okay, so you are just trying to see one nearby star. So what you will see is this star ka jo position hai, the nearby star, it will appear to be shifting its position with respect to the background. Okay, so the same thing what you see in the case of your finger in front of your face, will be able to see that same thing in the case of a far away star also. Okay, so this concept is known as something called parallax. Right, now what is the connection of parallax and parsec? Okay, as I told you, parsec is nothing but a parallax of uh, 1 arc second, isn't it? What I told you, what is parsec? Parsec, the definition of parsec is equal to parallax of 1 arc second, isn't it? 1 arc second is written as 1 and then double line. See, in degrees, you have 360 degree in a circle, right? Now degree, you can come down to 1 degree. Okay, then 60 minutes makes 1 degree, this you must be knowing. Now minute is also divided into smaller parts, so it is divided into seconds. So 60 seconds will be equal to 1 minute, isn't it? So 60 seconds makes 1 minute. Seconds is the smallest unit of angle. Okay, 60 seconds will make 1 degree. Sorry, 60 seconds will make 1 minute. Okay, minute, for minute you will put a single apostrophe, for second you will put two apostrophe. Okay, so 60 seconds will be equal to 1 minute and 60 minutes will make 1 degree. Is that clear? So this you should have back of your mind. So this 1 second, the angle of 1 second is known as 1 arc second, right? So this 1 arc second is nothing but the angle whose measure is 1 second, right? Now, parsec is what? It is a parallax of 1 arc second. The meaning of this is what? I'll try to explain you now. Now, suppose that this is the sun, okay, this is the earth, okay, and the average distance between the sun and the earth is say 1 AU, okay. You know that by definition of one astronomical unit, it is the distance between the average distance between the sun and the earth. This is supposed to be 1.5 roughly, or rather you take exact, it is 1.496. It is 1.496 into 10 raised to 11 meters. Okay, so this is the average distance. Now what happens, suppose there is a star which is somewhere over here. Okay, there's a star over here. Now if you try to see this star from the earth, okay, so this star is along this straight line. Okay, now this star is moving further away. Okay, so now there's this position. Okay, then further away in this position, what I'm trying to say is this star which you are trying to see from the earth along this line, along this perpendicular direction. Okay, what happens is when the star is nearer to the earth, okay, nearer to the earth, then if you join this line, okay, this angle will be larger. Now when the star moves, this is the first position or A position. Suppose star moves to B position. Now B position is still further away from the earth. Then if you join this line, uh, now I am being very uh, I'm trying to draw a very rough diagram, so don't get confused. Now, can you see this angle has reduced? Okay. So as an object moves away from the earth, these angles, this is theta 1, this is theta 2. And when it moves to the C position, that is still further away from the earth, then this angle, it will get still reduced, isn't it? This angle will get still reduced, right? Theta 3. These angles, theta 1, theta 2, and theta 3, these are the angles which will go on decreasing as the object moves further away from the earth. So when the star is at the A position, the angle theta 1 will be something. When the star moves further away from that A position to B position, okay, it is moving still further away from the earth, then this angle will change to theta 2, and theta 2 will be less than theta 1. And further, if this star moves still further away to this position C, okay, then this angle theta 3 will be still reduced. So you can say that theta 1 is greater than theta 2 is greater than theta 3. Okay, this angle goes on reducing. So as the distance increases between the earth and the star, what happens? The theta, that decreases, isn't it? This concept is used to understand this parsec. Okay. Now, let us try to understand in this triangle. Okay. Here I have written in this triangle SEO is a triangle, right? S is sun, E is the earth, SE distance is the average distance between the sun and the earth, which you have to take as 1 AU or 1.496 into 10 raised to 11 meters, right? And this EO is the distance between the earth and a star, okay, which is very far away. Okay, that star you want to measure, what is the distance of this star from the earth. So EO is something that you are going to measure, that distance you are going to measure in parsec. Okay, and this SO is nothing but the hypotenuse of this triangle. This triangle SEO, right? So in this triangle, if you see carefully, if you see this angle, okay, this angle is the theta angle I was talking about. Okay, so this theta angle, it will go on reducing as this object O, or rather the star, okay, is moving away from the earth. So more the distance between the earth and the star, lesser will be this angle theta. Okay, so when this angle is 1 second, okay, when the angle theta is 1 second, okay, 1 second means how much? It is 1 upon 3600 degree. Now these are the conversions that you should be very familiar with. How to convert minutes into degree, how to convert degree into seconds, how to convert second into degree. All this conversion you should understand very well. So assuming that you know how to convert this, I'll tell you that 1 second is nothing but 1 upon 3600 degree. Okay, and now the same thing I think I have explained here. If you want, I'll make you understand that also. uh, yeah, it has been explained over here. See, here I have tried to explain. See, start from here. 60 minutes is equal to 1 degree. Okay, 60 minutes is equal to 1 degree. Okay, so if you want to find out how much is 1 upon 60, okay, or let us start from here. 60 seconds is equal to 1 minute. Okay, the smallest unit of time is 60 seconds. Okay, sorry, the degree, the smallest degree is 60 seconds. Seconds is the smallest unit of degree. So 60 seconds will make 1 minute, and 60 minutes will make 1 degree. These two statements you understand properly. 60 seconds is equal to 1 minute, and 60 minutes is equal to 1 degree, right? Now from this, you will get 1 second equal to how many minutes? So 1 second will be equal to 1 into 1 divided by 60, that is 1 upon 60 minutes. So 1 second is equivalent to 1 upon 60 minutes. Now let us try to convert this 1 upon 60 minute into degree. So we'll take this relationship. 60 minutes is equal to 1 degree, and 1 upon 60 minutes will be how much degree? So if you cross multiply 1 upon 60 into 1, that will be 1 upon 60 divided by this 60. So multiply by 1 by 60. This will be the answer in degree. So 1 upon 60 into 1 upon 60 is 1 upon 3600 degree. So you get the answer as 1 upon 60 minutes is equal to 1 upon 600 degree. Now 1 upon 60 minute was nothing but equivalent to 1 second, isn't it? So can we say that 1 second is equal to 1 upon 3600 degree? Yes. So we can say that 1 second is equal to 1 upon 3600 degree. Okay. Now this is what I have done here. Okay. So let us go back. 1 second is equal to 1 upon 3600 degree. So here 1 second is equal to 1 upon 3600 degree. That has been written over here. Now, whenever this angle, okay, this angle between the lines joining the earth and the star and the sun and the star, okay, that angle, when that angle is 1 second, or in degrees it is 1 upon 3600 degree, 3600 degree, then this distance SO, okay, that is the distance between the uh, uh, earth and the star, is said to be 1 parsec. Okay, so 1 parsec is that distance which you get by taking this average distance between the sun and the earth as 1 AU, and this degree, the angle made by these two lines, that is SO and SC, has to be 1 second. If that is the case, then this SO distance is known as 1 parsec. So if this triangle is a right angle triangle. So if you write this EO is equal to 1 parsec, then when this EO will be 1 parsec, when SC is equal to 1 AU, and your tan theta will be equal to SC upon EO. Now this is a right angle triangle. This is 90 degree. This is theta. So tan of theta will be opposite upon adjacent. So opposite is SC and adjacent is EO. So tan theta will be equal to SC divided by EO. Okay. Now we are interested in this EO. So if you rearrange this, EO will be equal to SC upon tan of 1 second. Okay, tan of 1 second. So SC is 1 astronomical unit and tan of 1 second. Now this in trigonometry, you have to take the angle either in degree or radius. So 1 second, if you take it in degree, it will be 1 upon 3600 degree. Okay, so this EO, which is equal to 1 parsec, will be equal to 1 AU upon tan of 1 upon 3600 degree. Okay, and that calculation, if you do that calculation, also I have shown you over here. It's over here. 1 parsec is equal to 1 AU upon tan of 1 upon 3600 degree. Okay, this will be equal to, now 1 AU can be taken as 1.5 into 10 raised to 11 meter divided by tan of 1 upon 3600 can be written as 2.7 into 10 raised to minus 4, and tan of this 2.7 into 10 raised to minus 4 happens to be 4.71 into 10 raised to minus 6. So your 1 parsec will be equal to 1.5 into 10 raised to 11 meters divided by tan of this angle, and this whole calculation will work out to 3.1830 blah 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 into 10 raised to 16 meters. This, if you short down and write down, it will be 3.2 into 10 raised to 16 meter. So 1 PC is equal to 3.2 into 10 raised to 16 meter. Right? Now, if you want to find out 1 PC in light year, then what will be the answer? For that, what you do is you can use this. 1 light year is equal to 10 raised to 16 meters. Okay, 1 light year is 10 raised to 16 meter. Now, this calculation also I have showed you in the previous this thing. 1 light year is 10 raised to 16 meter. Okay, so how much light year will be equal to 3.2 into 10 raised to 16 meter? So the answer will be 3.2 into 10 raised to 16 divided by 10 raised to 16. So when you do that, 10 raised to 16 will cut off and you will get 3.2 as the answer. Okay, so 1 light year is equal to 3.2 sorry, 1 parsec is equal to 3.2 light year. Okay, so 1 parsec you get 3.2 light year, and 1 parsec is equal to 3.2 into 10 raised to 6 meters. Okay. So with this, I have made an attempt to make you understand these bigger units of length, which was astronomical unit, light year, and the parsec. Okay. So these three bigger units, that is astronomical unit, okay, then light year and parsec, PC. These three are the bigger units of distance. Okay, and these units are used for measuring terrestrial objects. Okay, that is the stars and the planets, distance between the stars, distance between the planets. For these purposes, these units are used. Now there is two more things that I want to discuss in this particular chapter, and that is something called the uh, two supplementary uh, physical quantities. Okay, in SI system, you have two supplementary physical quantities, right? I told you in SI system, you have 7 basic physical quantities and 2 supplementary physical quantities. So let us talk about these 2 physical supplementary quantities. Now, what are these 2 supplementary quantities in SI system? So just follow from here. Concepts of supplementary units of SI system, right? Now, these are the 2 supplementary physical properties, or say the name of them is plane angle and something called solid angle. Okay. So, plane angle is something which is connected to 2 dimension. Solid angle is something which is connected to 3 dimension. Now, these supplementary properties, physical properties, are neither fundamental nor derived. Okay. These are not coming in fundamental category also and derived category. They are totally independent, and there are only these 2 supplementary physical quantities in SI system, that is plane angle and solid angle. So let us talk about the plane angle first. Okay. Now plane angle is what that we'll discuss first, and its unit is radians. Okay. So plane angle ka unit is radian and solid angle ka unit is steradian. Okay, and it is written as SR. Okay, so these are the units and the physical quantities that comes under the supplementary units of SI system. Now, can you see this circle? Right, in this circle, suppose O is the center. Okay, now what you do is you take a arc AB. Okay, take this arc AB. Right, now join this OB and OA. Right, when you join OB and OA, then the length of this arc AB is said to be S. The radius of this circle is nothing but OB, which you take as R. OA will also be R. And the angle subtended by this arc at the center, this is known as angle AOB. Angle AOB is, which I have taken as theta. Okay, this angle AOB, which I have taken as theta, is nothing but the angle subtended by this arc at the center, right? So there is a relationship between this S, R and theta, right? There is a relationship between S, R and theta. That relationship is S equal to R theta. Okay, the relationship is S equal to R theta. If you rearrange this, you will get S upon R is equal to theta. Okay, this angle theta, this one, is said to be 1 radian. This is nothing but a plane angle. This theta is an angle which is a plane angle. Now, why it is a plane angle? Because it is a 2D angle. Okay, it is only in 2 dimensions. In a plane, okay, you can draw this angle. So it is a 2-dimensional angle. So this theta angle, okay, is a plane angle, and its value will be 1 radian if your length of the arc, that is S, is equal to the radius of the circle. Okay, so length of the arc and the radius of the same circle, the arc and the radius should be of the same circle. When these two are equal, then this angle theta, whatever angle is made, that angle theta is said to be of 1 radian. So here we come to know that 1 radian is an angle which is subtended by a arc AB at the center such that the length of the arc AB is equal to the length of the radius, or you can say it is equal to the radius, right? So when S is equal to R, okay, theta is equal to 1 radian, right? Now again, 1 radian is a measure of the angle in radians. Now if you want to convert this into degree, the relationship is this: 180 degree is equal to pi radian. So 1 radian will be how many degrees? So it will be 1 radian into 180 upon pi. 180 upon pi degree. And pi value you have to take as 3.14. Okay. Pi value you have to always take as 3.14. So 180 upon 3.14 if you do, you will get the answer as 57.3. So 57.3 degree is same as 1 radian. So that is what you get here. 57.3 degree is 1 radian. See, degree and radian are the two methods or the two ways in which plane angles can be measured. Okay, so that was about the meaning of a plane angle. What is the meaning of 1 radian, that is the unit of plane angle, that I have discussed with you. Okay, now if you want to define radian, here is the definition of radian. The radian is the plane angle, two-dimensional angle, subtended at the center of the circle by an arc whose length is equal to the radius of the circle, isn't it? So this subtended angle is that theta, and this theta will be equal to 1 radian when the length of the arc, that is S, is equal to the radius of the circle. So when S is equal to R, this theta is said to be 1 radian. Okay, so that is the definition of 1 radian, right? Now if somebody asks you what will be the radian of a half circle, okay, what will be the radian of a half circle? So half of the circle is nothing but pi radian, okay, which is nothing but 3.14. Okay, pi ka value is 3.14. So in radians, half circle will be pi radian. Full circle will be 2 pi radian. 1/4 of a circle will be pi by 2 radian, isn't it? In degrees, this pi by 2 radian can be written as 90 degree. In degrees, this pi radian can be written as 180 degree. In degrees, this 2 pi radian is written as 360 degree, isn't it? So these are the things that you should understand very well in physics before you go and take a huge dip into the field of physics, right? So these are the elementary things that you should know about physics. Now, once I have talked about this plane angle, let us talk about something called this solid angle. Now, what is a solid angle? Solid angle is similar to this plane angle only, but plane angle was a 2D concept. This solid angle is a three-dimensional concept. You must have heard about the fruit called watermelon. Okay, you know what is a watermelon. Okay, so if you try to get a watermelon which is slightly exactly circular, spherical rather. So this is a spherical watermelon. Okay, I'm telling you this because in the market you get watermelon which are not exactly spherical but elongated, elliptical in shape. So don't take those watermelons. I'm talking about watermelon which are perfectly spherical. Okay. Now suppose you have a watermelon which is somewhat very much spherical. Okay. So yeah, I'll try to draw that. Yeah. Oh no, this has become a little elliptical. So one more attempt. Yeah, one more attempt. Yeah, this is more like a spherical watermelon, right? Now, what you do with a knife, you try to cut a piece, a conical piece out of it. Whenever we go to buy a watermelon, those people, the vendor, he tries to cut a part of this watermelon to check and confirm that it's a good quality watermelon. Okay, so what he does is with a knife, he takes a slice like this. This particular slice, when it is removed, it looks like something like this. It's a cone like structure like this. Okay, it's a three-dimensional figure, right? Now this particular angle, okay, this is a solid angle. This is known as a solid angle because this is not a planar figure. Okay, it's a 3D figure. If you rotate this, okay, this angle, if you rotate either clockwise or anti-clockwise, you will get a figure like this. Okay, so this angle is known as a solid angle theta. Okay, now like in the plane angle, there was a relationship between SR and theta. So in this particular, now this is that watermelon, spherical watermelon. This is the center of the sphere. Okay, and this is that surface on the watermelon which you are taking. Okay, for example, this one particular area, small area. Now this, if you connect to the center of this sphere, these 2 points, if you connect to the center, this angle form is known as the uh, solid angle. Okay, now this theta solid angle has value equal to 1 steradian. Okay, this theta will be equal to 1 steradian when this area, this surface area on the watermelon, okay, it's a small part, okay, a small area. This area is equal to r square. Okay, so whenever this area is equal to the square of the radius, then this particular angle is said to be 1 steradian. So this theta, which is the which is the solid angle, is equal to this area element, that is the shaded, the pink shaded region, that area element divided by r square. R square is the radius of the sphere. Okay, so if you if you get this area of the surface as a and divided by r square, okay, and suppose they are not the same, then you will get some theta value. Okay, that will be 1, 2, 3, whatever. It will not be 1, but it will be something. But as soon as this area of the element, okay, the surface area becomes equal to the radius square, then whatever central angle, I mean this solid angle will be formed, that angle will be taken as 1 steradian. Okay, so if you want the definition of this steradian, then once the steradian is a solid angle, and solid angle, because it is a three-dimensional angle, subtended at the center of the sphere. So this angle is also subtended at the center of the sphere by an area element. Now this pink shaded region is the area element. Now this is that area element. Okay, so by the area element whose area is equal to the square of the radius of the sphere. So this steradian is 1 steradian is that angle where this element area and the radius square both will be equal. Okay, so when that these two are equal, we say that the solid angle is equal to 1 steradian, right? Now suppose instead of this small element area, okay, or this small area element, okay, you take the entire surface area. So you know that the entire surface area of a sphere is 4 pi r square. That 4 pi r square divided by the radius square, that will be r square. You will get what? R square and r square will cut and you will get 4 pi. So for the entire sphere, the solid angle is always equal to 4 pi. Okay, now in that way, if you want to find the answer for half of the sphere, okay, for half of the sphere, what will be the uh, this thing, solid angle? For half of the sphere, the solid angle theta will be equal to, now for half of the sphere, the surface area is 2 pi r square, isn't it? That divided by the radius ka square. So r square and r square will cut and we will get 2 pi. So 2 pi is the 2 pi SR, steradian, is the value of the solid angle for half a circle. Okay, that way the concept of this solid angle can be understood. Now consider a sphere of radius 7.1 centimeter. Okay, suppose you have a sphere, suppose it's a watermelon whose radius is 7.1 centimeter. Now what can be done is you can find out this r square. So r square will be equal to 50 centimeter square. 7.1 into 7.1 is 50 centimeter square. Now the solid angle of one steradian of this particular sphere. Which sphere? The sphere whose radius is 7.1. Okay, how you will get? So theta in bracket 1 steradian will be equal to a upon r square. A will be how much? A will be equal to 50. Now how you got this a? This a you got as 4 pi r square, that is equal to 4 into pi into 7.1 square, isn't it? So when you do this 4 pi r square, you will get the surface area as 4 pi r square. So that will be equal to 50. Okay, now no, the thing is this theta will be one steradian when this area, both this area will be same. This area and this r square will be same. So suppose the r square is 50 because we have taken r as 7.1. So suppose the surface area of this is also 50, then 50 upon 50 will be equal to 1 steradian, isn't it? So suppose this area, this shaded area, pink color area, okay, is also 7.1 square, that is 50 centimeter square. Then this angle theta will be nothing but 1 steradian. Understood? So 1 steradian, 1 SR is that angle theta for which the uh, area element, this shaded part, okay, the pink element, okay, that area and the r square both will be same. Okay, so this r square and this will also be a equal to r square. When that is the situation, this angle, this solid angle will be equal to 1 steradian. Okay, so theta is equal to 1 steradian when the area element is of 50 centimeter square and the radius square is also 50 centimeter square. When these two are equal, then only this angle will be 1 steradian. Now for a whole sphere, solid angle will be how much? 4 pi r square upon r square, which is 4 pi, and this 4 pi works out to 12.56. Okay, and for a half sphere, that is hemisphere, it will be 2 pi r square upon r square. So r square will cut out and we'll get 2 pi. 2 pi is nothing but 6.28 SR. Okay. Now, what is the meaning of this 2.56? When you take a watermelon, okay, whose radius is whatever is the radius, but if you take a piece, okay, which is of this form, okay, this angle is 1 steradian, right? Then how many such pieces will be you can remove? So you can remove 12.56. So between 12 and 13 pieces you can remove. So this type of conical pieces you will get how many? 12 to 13, between 12 and 13. Okay. So or in other words, if you take 12 or 12.56 such cones and if you bring them together, you will get this sphere. Okay. So that is all about this steradian angle and the plane angle. With this, I have completed this units and measurement chapter ka first part. Okay, that is the length ka measurement and the units. Okay, so length we have covered. Now in the next video, I'll be starting with the mass ka units and the details of that, and then we'll be coming to time. Okay, so in this chapter of units and measurement we'll be dealing with so many things. Now when you are dealing with mass, what are the different system, that is SI system, CGS system, what are the units used for measuring mass, all that we are going to discuss. Then for time, what are the units used, what are the instruments used, all that we are going to learn in this particular chapter, that is units and measurement. So this today's session I'm going to stop here and here itself, and we'll be continuing from the further in this chapter. We'll go in the next video. Till then, goodbye, take care all of you. Please subscribe my video if you like it, okay, and that will motivate me. Bye, take care all of you.